This is Unit 6, Day 7. Today is solving rational inequalities. So now guys, don't forget, an inequality is greater than, less than, greater than or equal to, less than or equal to. Okay, so today's a pretty hard concept. I'm going to try and simplify it as best I can, but it's also a way you could do this is by sign analysis that we teach in pre-calc as well. So that might be something you want to look into. All right, example 25. Consider the rational inequality, and it's stated there. It says, at what values of x is the whole thing equal to 0? Now, in order for a fraction, think fraction, right? You have any fraction. In order for it to equal 0, you will have 0 over any number to equal 0. So it says, hint, a fraction is equal to 0 only when its numerator is 0, right? And then the opposite of that is, you're going to see in a minute for part B, it says, when is it undefined? Okay? If you have any number divided by 0, so there's a 0 on the bottom, the denominator, that's undefined. So these are two really key major concepts right here. So when the numerator is a 0, it's 0. When the denominator is 0, it's undefined. So now when this says, when will it be 0? You know that that's when the numerator is 0. Okay, so what you're going to do, take the numerator, which is x minus 5, set it equal to 0. Okay, again, only focusing on the numerator. And if you add 5 to both sides, you're going to get x equals 5. So now it says, is this value a part of the solution set? Well, test it. 5 minus 5, okay, so all I'm doing is substituting in a 5 where I see an x. You want to check and see, is that greater than or equal to 0 when I have 5 plus 3? So again, substituted in a 5 wherever I saw x. I end up getting 0 over 8. Is it greater than or equal to 0? And 0 on the top is a 0. So 0 is greater than or equal to, yep, it's equal to 0. So yes, okay, it is a part of the solution set. Okay? Part B. In order for something to be undefined, it's when the denominator is 0. So take the denominator piece of it, set it equal to 0, and it's when x is negative 3. It says, is this a part of your solution set? The answer ends up being no, so this one was yes up top. No, and here's why. Plug in a negative 3 wherever you see an x into the original inequality, and you end up getting negative 8 over 0. Is it greater than or equal to 0? Undefined, because that's what it is when 0 is on the bottom, is not bigger than 0, and it's not equal to 0, so it is no, and that's why that one's a no. Okay? Part C says, set up a one-dimensional number line, okay, using the values that you found from part A and B. So remember, our number line was, the denominator was equal to negative 3, and the numerator was equal to 5, okay? It can never, ever, ever, ever be included where it's undefined. So undefined is always, always an open circle, okay? It's not included. And then the rest, we're doing test values, guys. So you're literally going to plug in 5 and see if it works. It did. Why did it work? Because when we plugged in 5, it was included. Why? Because you got up here, 0 was greater than or equal to 0. That one's included. That one gets shaded. Okay, back up into part A. But now you have to pick all kinds of test values in between. So you can say to yourself, what's between negative 3 and 5? Guys, the easiest one to pick is 0. So test 0. Okay? I'm going to test 0. You can pick any number lower than negative 3. So go pick negative 4, go pick negative 10, it doesn't matter. And pick any number greater. And you're going to test that as well. Okay? So you're literally going to substitute these in now. You are going to pick 0. So go back to the original and say, okay, I'm only going to show the work for this first one. You can do this in your calculator, and it's huge, guys. Store it. So do 0, store as x. Put the original in, or if you did it by hand, it's going to be 0 minus 5 all over 0 plus 3. Is that greater than or equal to 0? So I'm testing the 0 value. So I end up getting negative 5 over 3. Is that greater than or equal to 0? Well, guys, if it's a negative number, it's not greater than 0. So that's not true. So that means right here, this is a no. What does that mean? That means any number in between these are not included. So don't draw your line and connect them. Okay? Then I'm going to test 6. So I'm going to try, is 6 minus 5, so I'm testing 6. Is 6 minus 5 all over 6 plus 3 greater than or equal to 0? So I'm going to get 1 over 9. Is 1/9 greater than 0? Now, who cares that it's 1/9, guys? Okay? When you divide 1 divided by 9, you get 0.111 repeated. Who cares? It's still greater than 0. So this one is a yes. That means everything to the right of 5 is a yes. Because it's a yes, you extend your line that way. All right? Our last value that we're going to test is the negative 4. So I'm kind of running out of space there. So I'm going to come over here. So I'm going to go negative 4, and again, going back to the original, negative 4 minus 5 all over negative 4 plus 3. Is it greater than or equal to 0? I get negative 9 divided by negative 1. A negative divided by a negative would be positive 9. Positive 9 is greater than 0. That ends up being a yes. So because that is a yes, that means all the values down here is also included. So now if you guys look at my answer right here, okay, we did a number line test. It's going to be, now it says, if you guys pay attention here, it says write it in set builder and also write it in interval. So the set builder notation would be from x is less than negative 3, because it's anything less than negative 3. And then you say, or x is greater than or equal to 5, because it's going to start at 5 and go higher. In set builder notation, that's where you have the curly brackets. Okay, so this is my set builder notation. Again, running out of space. I apologize. So this means for all x such that x is less than negative 3, so it's everything falling lower. It does not include it. Remember, that's where it's undefined. Or it's going to be x is greater than or equal to 5. Okay, that's set builder notation. Interval notation, where am I starting way over here? Negative infinity, never included, so it's smooth. All the way up to negative 3, not included, smooth. You could write out the word or that symbol is the union symbol for or. And then include square bracket 5 going to positive infinity, smooth. This is interval notation. Okay? So these are known as the critical values. So negative 3 and 5 are our critical values that we're testing, and then we test in between. Okay? It was a lot at once, but you're going to see what I throw at you in a minute. All right? So now, here we go. So this one is set equal to 0. Okay, so pay attention to that. So example 26 says, solve each rational inequality for all values of x. Show your solution on a number line and state its solution in, it wants it in set builder again, and interval notation. Okay, so remember, you set the numerator equal to 0. Okay, that's what we did before. So numerator equal to 0. So x squared plus 3x minus 4 has to equal 0. How do I solve that, guys? The only way to do that, and again, let me make a little note, this is my numerator, is to factor, okay? This is a trinomial, so what multiplies to negative 4 but adds to positive 3, you're going to get it's plus 4 and minus 1. Split, you're going to get x equals negative 4 and x equals positive 1. Okay, so those are two critical values that we're going to throw on the number line in a minute. In order for the denominator to be undefined, that means set the denominator So denominator, to make it undefined, you're going to set that equal to 0. So take your x squared minus your 6x plus your 9, set that equal to 0. You're going to factor that. You're going to get x minus 3, you split, and you get a repeated number of 3. Okay, you don't write that twice. So now here's my critical values. Start with a number line. Okay, go from, you have to be in order from least to greatest. So I have a negative 4, I have a 1, and I have a 3. Okay, where it is undefined, which is right here at 3, okay, how do I know? That's the denominator one, that's where it's undefined. That one is never, ever, ever, ever included. Okay, so I know that that one automatically is going to be an open circle because where it's undefined is not included. Okay, to test the other ones, you have to see, can negative 4 be included? Can 1 be included? Okay, and then you're also going to pick your test values. So 0 is always an awesome one to test. So I'm going to test 0. What's between 1 and 3? Don't say only 2. 2 makes sense to test, but don't forget you can also use like 1.5. You could use 1.25. You could use 1.75. Okay, you could use 2.5. Okay, but whole numbers work better. What's on this side? You could test 4. We got a lot of test values. And then you got to go 1 to the left of this. You could test negative 5. Lots of test values. Okay? If you use your calculator, life is so much easier. What do I mean? I mean, make sure you test out. You have to test these critical values too. You have to test negative 4 and 1. But let's say you start with negative 5. Okay? So what you're going to do is you're going to go to your calculator and you're going to store negative 5. So go negative 5, store it as x. Okay? I'm going to do this at the same time that I'm talking to you guys. Oops. Okay? I tried to store it as 5. Store it as x. Okay? And what I'm then going to do is I'm going to copy this whole thing in my calculator right now. So I'm going to start a fraction. I'm going to write x squared plus 3x. And then I'm going to do minus 4. And then the denominator is going to be x squared minus 6x plus 9. Now, in your calculator, your x's should be bold in your calculator screen because you stored them as negative 5. Hit enter. And when I test 5, I get 3 over 32. So if you guys did that in the calculator with me, you'd get 3 over 32. What is that as a decimal? That's approximately 0.09375. Okay? So when I substituted in a negative 5 to this whole original thing, I get approximately 0.09375. Is that less than 0? No, that's not. That means in this area, this gets a big no. So you don't include any numbers to the left of negative 4. Then you can store negative 4. So negative 4, store it as x. Okay? You don't have to type that whole big thing in again. Just go up and highlight it, and I get 0. So when I tested negative 4, okay, and if I stored that one as x, when I go back in and plug a negative 4 in here, I get 0. Is 0 less than 0? No. What does that mean? It's an open circle at that critical value. You cannot include it. Okay? Then go test 0. When you test 0, 0 is probably easy to do in your head. When you put in zeros here, wherever you see your x's, you get negative 4/9. Negative 4/9 in your calculator is negative 0.4 repeated. Is that less than 0? Why do I keep saying less than 0? Because that's the inequality that was given to you right there. Yes, that is less than 0. So that means in this area, between negative 4 and 1, I get a yes. Okay? So I'm going to connect that in a minute. I just have to test 1 to see if I'm going to shade 1 in or not. Okay? So I'm going to test 1. 1, store it as x. Okay? I'm going to pause this because we're running out of time here.